Hello, my name is Keshwani. That's Keshwani. Keshwani. We are here because we want to learn algebra. Today is our lesson number 76, day number 76. Starting from today, we're going to learn how to divide algebraic expressions. The first 20 days of the course, we learn how to evaluate algebraic expressions. Over the next 30 days, from day number 21 through 50, we learn how to add and subtract algebraic expressions. AE stands for algebraic expressions. And then over the next 25 days, from day number 51 through 75, we had been doing multiplication of the algebraic expressions, and today we're going to learn how to divide. Again, in the beginning, they're going to start out in a very simple manner, very simple problems, very easy problems. And as we go up higher in the days, they're going to get a little bit more complicated. So here's the first one. 33x cubed over 11x. Well, 33x cubed is same as 33 times x times x times x. That's what x cubed means. X cubed means multiply the x by itself 3 times. X times x times x. That's what x cubed is. And then at the bottom we have 11x. We can divide the top and the bottom by 11, and if we were to divide the top and the bottom by 11, we can get rid of this 11. This 11 becomes 1, which of course, because it becomes 1, we don't actually have to write the 1, because everybody understands that if there is nothing there, there is 1. And 33 divided by 11 is 3. X divided by x, that x cancels out, and then we're left with 3 times x squared. How could we have shown that work without having to go through these baby steps? Like this. 11 divided by 33 is 3, and x divided by x cubed is x to the second. That's how we show it. X cubed divided by x in a grown-up method. You see, this boils down to 3x squared. You see, x times x squared. In a grown-up method, you show it like this. X cancels out, and this third power becomes a second power, x squared. Or you can do it like this. X cubed over x equals x squared. So that's what we did here. This x cancels out, and this cube becomes squared. That's it. That was the answer. Answer is 3x squared. Let's do the next one. How do we show a quantity squared divided by the quantity? Well, again, there are a couple of ways. One is a very elaborate and very simple method, baby steps if you like. Elaborate in that sense, elaborate not in the sense of complication, but elaborate in the sense of having to show the baby steps, which is this. X squared is 3 times 3 over 3, and then you cancel out the 3. This is one way to show it. Another way to show the whole thing in a grown-up method would be this. There we go. So when we cross out the power, what power does 3 have now? It has a power of 1. It doesn't have a power of 0. 2 became 1. And because it's 1, we don't have to write it. That's just 3 right there. See? 9 divided by 3 is 3. Let's do one more. X squared divided by x is same as x times x over x. And then you can cross out these two x's and you're left with x, or you can simply do this. Cross out the power. The power becomes 1. And since it's x raised to 1, we don't have to show the 1. That's all. Which is same as, for example, y raised to 5th divided by y, which is simply y raised to 4th. 5 becomes 4. That's all. Let's do one more. The next one we have is 9x squared. 9x squared over 3x. Well, 9x squared is same as 3 times x over 3 times x. Don't get confused. This is my times sign, multiplication sign, and this is my x. For multiplication sign, I raise my hand. Rather, not raise my hand, rather, I lift my hand. And x is just this, without lifting my hand. So, we have 3 times 3 in the bottom, we have 3. If we were to divide the top and the bottom by 3, the 3 cancels out. And this x will cancel out with this x, and we are left with 3 times x. How could we have shown this thing in a more grown-up method without having to show these baby steps? Like this. 9 divided by 3 is 3, and 3 divided by 3 is 1. Because it's 1, we don't actually have to write that 1 if you didn't want to. Similarly, this x drops out with this x squared and becomes x. So we end up with 3 times x. Voila, 3x. Let's do one more. Let's do one more. 24 a to the 4th. 24 a to the 4th over 8 a squared. Well, 24 a to the 4th is the same as 8 times 3 times a times a times a times a. A being multiplied by itself 4 times. I do not like the looks of it. It looks pretty ugly. It looks pretty distorted. I'm going to have to redo it. I know. But it's important that the things look neat. 24 a to the 4th over 8a squared, which is same as 8 times 3 times a times a times a times a. That looks much better. Over 8 times a squared, which is a times a. Voila. So what can we do? Well, if we were to divide the top and the bottom by 8, this 8 will drop out. And if you were to divide the top and the bottom by a, this a will drop out. And if you divide the top and the bottom one more time by a, this a drops out. So we're left with 3 times a squared. Now notice I always speak in terms of top and the bottom. I don't care about the terminologies or the jargon and so forth. Your algebra teacher will frown upon that. Your algebra teacher would not like that. My referring to this thing as top and the bottom. Your algebra teacher would refer to these as the numerator and the denominator. As far as I'm concerned, they're top and the bottom. Alright? Alright, so the answer here is 3a squared. 3a squared. How could we have shown the same work in a more grown-up method without showing all this intermediate step? Well, like this. If you divide the top and the bottom by 8, the 24 becomes 3. If you divide the top and the bottom by a squared, this a squared goes away and this 4 will become 2. Voila. That's it. So it's 3a squared. And you can't just leave it like this. At the end, of course, you have to write your answer. You have to show your answer, which is 3a squared. This is too sloppy. You have to finally write your answer. This is it. 3a squared, you see? That was it. That's it for today. I will see you tomorrow on day number 76. I'm going to probably do this division problem that we're doing here, dividing algebraic expression, not for 25 days, maybe for, here's the game plan. You see, listen carefully. I'm going to do them probably only for 10 days. I'm not sure yet. And then I'm going to start the linear equations from 86 to 100, because I want to start the word problem, and when I start the word problem, each day I'm going to do one word problem each day, and it's easier to keep track of the numbers of the word problem if we were to start with 101, because I want to do 100 of them. So we're going to go from 101 to day number 200, doing one word problem a day for 100 days. And if you do all of those 108, if you do all of those 100 word problems with me, by the end of that 100, you'll be very good at setting up algebraic equations, and your fear of word problem will be gone forever. You understand? That is the plan. We'll see. One will see what one will see. One will see what one will see is a... I know we are done. This is a bonus if you're still... Listen, I want you to look up this word and learn it. I'm not going to explain to you what it is. I'm just going to simply use it in a sentence. One will see what one will see is a tautology. What is it? It's a tautology. Day number 38. Type in KeshwaniPrep-vocab-day 38. Learn this word, tautology. I will see you tomorrow, okay? Bye bye.